Do we live in a universe that is fine-tuned for the existence of life? And if so, how is this best explained? Today I bring on the expert, none other than Dr. Luke Barnes. And Dr. Barnes is a postdoctoral researcher at Western Sydney University in Australia, and he works on cosmology, galaxy formation, and the fine-tuning of the universe for life. He's also the author of the book A Fortunate Universe, Life in a Finely Tuned Cosmos. I'm super excited to have him on, and I'm sure we're going to have a great conversation, so stick around for that, of course. And if you enjoyed the episode, be sure to hit the like button, subscribe, leave us a review, and if you want to watch the bonus segment, 5 more minutes with Dr. Luke Barnes, be sure to follow the link in the description below, labeled Support Help Me Believe, and become a patron supporter. Hope you guys enjoy the episode. Well, hello and welcome to another episode of Help Me Believe, the show about Christian apologetics and theology. My name is Haden Clark, your host, and I am excited to introduce my special guest to you. His name is Dr. Luke Barnes. Dr. Barnes, how are you doing today, sir?
I'm doing very well.
Very good. Everything's going well in Australia?
It is. It's 10 a.m. over here. I'm not sure what time it is over there, but yeah, so far it's a lovely sunny day.
Yeah, 6 p.m. in Texas and then 10 a.m. over in Australia. It's what a time to be alive that we can connect like this. It just blows my mind, really, it does. But this is very neat, and I do greatly appreciate you taking the time out of your morning to come on to the podcast and do this. I really appreciate it. But for those who may not be familiar with who you are, I thought it might be helpful to give a brief introduction.
Yeah, so I'm a cosmologist and an astrophysicist. Cosmology is the science of the biggest features of the universe, and astrophysics is trying to understand the details of things in the universe, and the bit that I'm interested in is the overlap where, if we can understand how galaxies form, we'll understand something about how the overall universe is structured, and so those two feed off each other. I'm Australian, grew up in Australia, did my undergrad at Sydney University, did a PhD at the University of Cambridge, and then worked in Switzerland for 2 years, and have been back at the University of Sydney, and I'm now at Western Sydney University as a postdoctoral researcher.
Very cool. Well, thanks for sharing. And just kind of to get us started here, what kind of got you interested in science and cosmology and all that good stuff kind of in the first place?
So I was always a bit of a nerd growing up, but actually I was a bit more of a dinosaur nerd as a kid.
Oh, yeah, me too, actually, as a kid.
Knowing all the names. So for example, I was in New York recently and went to the Natural History Museum, and straight for the dinosaurs, even now. Maybe I'll have time for the astronomy stuff later, but who knows. But then in high school was good at maths. And in particular, when I studied physics in high school, I thought it was really kind of amazing that that you could, solve problems about the real world with mathematical equations. So I then, after, not quite sure what I wanted to do after high school, I did a physics degree. And really, really enjoyed that, and so went on to do, a master's and a PhD in these sorts of things. So I started off in physics, and then got interested really in cosmology and the bigger scales, and then through that got more and more interested in the smaller scale stuff about how how individual things in the universe work. So sort of the details about how stars form and how galaxies form and all that sort of stuff.
Yeah, great. Well, if you don't mind sharing with us, how did you come to be a Christian? How did you come to faith? And how has your scientific education affected that at all, or if it has at all?
So I grew up in a Christian household, but one that was actually sort of a young Earth creationist background. So that's not what I believe at the moment. But and so I got interested. That was kind of one of the things that got me interested in science, as well as the fact that I could that I could do it. Yeah. And so for me, a lot of the questioning about Christianity came in the context of, okay, I hear a lot of people saying that science kind of is the end of Christianity, and the more you know about science,
Yeah.
the less you'll be inclined to be a Christian. And a PhD from Cambridge and coming up now on 10 years as a research scientist, and that still hasn't happened. So there's been a lot of
So
looking closely at what I believe, of course, but
yeah.
I think I'm more convinced that there's a God, certainly,
Right.
than I was, before, or at least I can articulate it better.
Yeah. So it never really has occurred to me why that would be a problem for people either. But do you know why people view it this way, and why has it never really affected you?
So there's two things I think it comes down to. One is a conflict between science and young Earth creationism. So if you think the universe is
Sure.
6,000 years old, then you've got some explaining to do, at least.
Yeah.
But as I looked more into that, there's more than one way to interpret Genesis. Is the short
Yeah.
story there, and I could see that was true even before, the scientific revolution.
Yeah.
So
Definitely.
there's that side of things. I think the other side of things, there's a whole bunch of pretty terrible arguments that go something along the lines of, we used to think that God caused things in the universe, but now we have science. We used to think, the gods caused thunderstorms, but now we know about, clouds and weather and such. We used to think that we were the most important bit of the universe, and science has shown that's wrong. God of the gaps, all that sort of stuff. And
Yeah.
all of those, they fall apart in your hands as soon as you look closely at them, all those sorts of arguments.
Yeah, yeah, for sure. I guess it's never really ever that is science as an objection to faith has never really bothered me because whenever I hear people argue from Genesis for a young Earth and stuff, I just am like, I don't think the Bible is a science textbook, and so I don't think it really gives us a position to take here, and so we're free to take whatever position we want based on the scientific evidence. And then as far as God goes, like my arguments for the existence of God are largely just philosophical arguments. I'm not a scientist.
Yeah.
I couldn't make the fine-tuning argument if I wanted to because I don't have the background even from a lay perspective to do so. But anyway, look, that's all interesting, but we are here to talk about the fine-tuning argument, and I've heard you discuss this. You actually had the opportunity to discuss this with the well-known Sean Carroll over at Justin Brierley's show, and so that was really good to listen to. And so that's kind of where I think I first heard of you, and then I was like, I want to definitely have a conversation with this guy, Luke Barnes, and so I'm happy for you to be here. But just kind of briefly or broadly, what is the fine-tuning argument, or how would you define fine-tuning, I guess, just for the audience?
Sure. So I think if we go into this via the fine-tuning argument, I think it's kind of an extension of just we're all amazed at nature as we see it around us.
Yeah.
So there's an old argument due to Paley and even before then that just says, look, if you're walking across a heath and you kick a stone, then that stone might have been there forever. But if you're walking across a heath, English of course, a heath, and you find a watch, you're not going to be happy with just saying it's been there forever.
Right.
And supposedly what happens next is, we used to think that the natural world was made by God, but actually then Darwin showed it could come about via natural processes.
Right.
And what I'd say about that is that's not refuting Paley's point. It's just asking for a rematch.
Mm-hmm.
It's a bit like saying, we used to think that this watch was made by a watchmaker. We now know it was made by a watch factory.
Right.
Okay, well, you're now asking for a rematch. Would it be okay to say that the watch factory had just been there forever and just is there? And obviously not. Okay, so what's happening here? We look at the natural world around us. We see amazing things. The natural inclination of basically everyone everywhere has been to say, there must be some sort of person who put this together and thought about it and has the power to do that sort of thing. I think that's why the belief in God is so widespread, amongst other reasons.
Right.
But then the critic says, no, we've got natural processes that can make these things. And so that's asking for a rematch. Let's now look at the natural processes. So we can look at chemistry. And they say, well, no, they're based on physics. So If you want to just say, look, the natural world is amazing, I think that's a good argument. But if you then want to counter this, all right, but what about the natural processes? The thing that sends us towards is let's look at the deepest laws of nature as we know them and see if we see in them the kind of, amazing, well put togetherness, property of whatever it is about the watch and the world we see around us. Do we see that kind of, these things are well put together? And one of the ways you might want to do that is to say, okay, well, here's something about the watch. If you took the watch apart and then reassembled it at random, just attached random bits to random bits, the watch wouldn't work. If you took the watch apart, took out one of its pieces and replaced it with a slightly different piece, probably the watch wouldn't work. Like if that little cog is just a little bit, I'm thinking of an old school, old-timey cogs and wheels and stuff. If one of those cogs is a little bit too big or a little bit too small, it won't fit, the watch won't work either. So the thought is, okay, we've been sent towards the deepest laws of physics. Let's look at those pieces and just change them a little bit. Mm-hmm. So, we're all made of protons and neutrons and electrons. Actually, protons and neutrons are made out of quarks. So far as we know, that's the basic level. That's as deep as we can get, right? So let's just go there because that's as deep as we can get. And let's start changing those numbers and seeing what happens. Mm-hmm. And fine-tuning is simply the discovery that was made really in the physics literature before any philosopher thought they could do something with this. But the physicists are saying, all right, if you change these numbers a little bit, you end up kind of ruining the universe. You get the, the watch doesn't work. In this case, the watch is, chemistry. The periodic table doesn't work anymore. You can't make all the elements. You can make sort of, maybe hydrogen, and that's about it. So the fine-tuning argument is just, look, if you're amazed by the natural world around us and you think that our universe is kind of a at some level, some sort of life factory, then the factory is at least as amazing as the life that it produces. It's not a randomly thrown together bunch of stuff. It has a very unique ability to actually support and sustain life as we know it or as we can imagine it.
Wow. Okay, so do most scientists agree that the universe is indeed fine-tuned for the existence of life?
So we've got to be really careful at this point. So the word fine-tuned or fine-tuning it's kind of a metaphor within physics. There's a bit of physics jargon.
Sure.
So if you're asking, do most scientists think that there is a creator of the universe who has set things up just right for life?
Right.
The answer is, well, we do those surveys, and the answer is probably not.
Right.
However, when a physicist says something is fine-tuned, they don't usually mean, created very precisely by God. Right. What a physicist usually means is a bit of jargon that just means you've had to make some very precise and particular assumptions in order to explain something. Yeah. If you're putting together some model of the universe in order to make have some weird and unexpected coincidence happen, then we say that that's a bit fine-tuned. Your model in and of itself could have had all this range of outcomes, but you needed this specific one, and so you had to turn the dial to there.
Gotcha. Yeah.
So in that sense, in the purely physics jargon sense, it seems that there is at least fairly widespread agreement in the sort of facts I was talking about before. Change these fundamental numbers by a little bit and you end up with a universe that couldn't plausibly support life.
Gotcha.
That conclusion is upheld by a lot of, certainly within the literature. You might hear some people slagging it off, but they never do it actually in a paper. If you've read through the physics literature, that premise is very widely supported by basically everyone who writes on this.
Okay, very cool. So I thought it might be useful to give maybe a few examples or just a really good example that exemplifies fine-tuning. And so I'll turn it over to you. What is maybe the most amazing discovery of fine-tuning or something like that in your opinion?
So let me give three. I've sort of given one already. The masses of the fundamental particles, like you're made out of three particles. You put those together in the right order, and you can make all of the stuff that you can see. That's kind of amazing. The up quark, the down quark, and the electron. And relative to the sizes that you could put into our physics and they still make mathematical sense, relative to those scales, you have to fine tune all of those numbers to be quite small, sort of 10 to the minus 17. So 1 over 1 with 17 zeros after it, that sort of level. So that's a particle physics fine tuning about the basic stuff of the universe. Also, the overall cosmology, structure of the universe, there's fine tuning there. The most famous example is known as the cosmological constant. So the easiest way to explain this is, our theory of the fundamental stuff of the universe, electrons and particles and all that sort of stuff, actually describes these things as fields. So an electron is really sort of a little wave in an electron field.
Okay.
And what was discovered was you can describe, given this field, there's a way to describe there's one particle here going that way, and there's a way to describe there's 10 particles here going in all sorts of directions, and there's a way to describe there are no particles here, and that's called the vacuum for obvious reasons. There's no particles there. And all that means if you stuck in a particle detector, nothing would happen. But even though particle physics there's nothing there in terms of particle physics, the universe as a whole, the expansion of the universe, depends on whether there is energy left there, even when there are no particles. So there's still a field there. If there's still energy there, that will make the expansion of the universe change in certain ways. Particularly, it can accelerate and decelerate. Okay. What we've discovered is our universe is sort of very slightly accelerating due to something that looks a lot like vacuum energy, but we can't quite confirm that. But again, the fine-tuning question is, what's the range that this dial could have? And it turns out the range is enormous. What range would it need to be in order for anything interesting to happen to the universe? And that number is absolutely tiny. And we're talking 1 part in 10 to the power of 100 at least. So 1 with 100 zeros after it. So given the range, if you're not in there, you just have a universe which is mathematically fine, but is so sparse that no particle ever meets another particle. Wow. So you can think of how many particles there are in this room. None of this sort of stuff happens. No particle ever hits another one. Yeah. It's worth saying that there are examples where we thought there was a fine-tuning case, but it turned out there wasn't.
Really?
So it's important, So it's important actually to give the counterexamples. When you do a fine-tuning case, what you want to say is, how would the universe have turned out if I turned this dial? Okay. And one of the things that was noticed in the sun, 2 protons come together, they have a nuclear reaction, and then that produces the energy in the sun. But it can't do it directly by 2 protons sticking to each other. They don't stick. You have to bring them together enough that something called the weak force turns up at just the right time. A proton turns into a neutron, and then a much slower thing has to happen. So the thought was, if you changed physics a little bit so that 2 protons could stick to each other, like if you could do that in the sun right now, the sun would basically explode. It would burn through all of its available energy, not over the next couple of billion years, but in about 1 second. And so that sounds like a fine-tuning case. If you change this number, stars would be explosive. The problem was they didn't do it right. What they did was, let's take our universe and then just change that number. But that's not fine-tuning. You have to start a whole universe again, change that number at the start, and then let the whole thing play out. And one thing that was sort of suspected in the literature, and then I wrote about a paper about it in 2015, was actually you can make stars in that universe. You just have to back them off a bit. They have to be a bit less dense and a bit bigger and fluffier. But they'll still work. So you have to be a bit careful with fine-tuning cases, but there are some very solid ones, as I've said.
Okay, so even though there's some counterexamples, there are some examples like the cosmological constant that you would say it's not likely, or that's going to happen with something like the cosmological constant. Yeah,
so it's not quite. You say counterexample. Just to be precise about
Sure, yeah, sorry.
If I say something's improbable, so suppose to win this game, I have to win the lottery 3 times, right? Yeah. And then you say, oh no, it's fine. You only have to win it twice. that final lottery's okay. You've still got to win the lottery twice, right? So
Yeah.
the three examples I give are sort of, we got to win the lottery here, we got to win the lottery here. We thought we had to win the lottery a third time. Actually, no, that one's fine. You'll get that
Right.
one for free. There's still two lotteries. So
Yeah.
this one does nothing to annul
Right.
those ones.
Right.
You just have to be a bit careful.
But there are a number of them, actually. It's not like it's just the cosmological constant. There are a number of them. And would you say that we don't just need one of them for life to be possible? We actually need them all, correct?
Sure. It's not true that every fundamental constant needs to be fine-tuned. There are about 31 of them, and a lot of them deal with things like, weird properties of neutrinos, which are this particle that never interact with anything anyway. But there's about a dozen where you've got to get them right. And in particular, so for example, you could get your periodic table perfectly fine, but if your universe expands too fast, you could have made carbon, but you never actually do, because you never get 6 protons together at all in the history of the universe. So no, you do have to get them all.
Yeah. Okay, so whenever you look at something like the cosmological constant and the odds of that are, very great, whatever you said it was, like 10 to the 100th or whatever.
Yeah.
I'm not a philosopher, somebody that studies like probability theory and stuff, but don't you kind of have to take not just that one, but all the other fine-tuning examples and say the odds of this are just so vastly even more than just the crazy odds of just one of them?
Yeah, so when I think if you set the problem up right, and you have to be a bit careful about this, but once you've set the problem up right, you can actually multiply those probabilities together.
Yeah.
You've got to deal with fundamental constants. You've got to justify why you're assigning the probabilities you do. I think that work can be done. But then so I think you end up with a number that's about, the cosmological constant's the main one. It gives you sort of 100 powers. I think there's another 30 powers to be found lying around the place with the other constants. So 10 to the 130 is my best sort of guess for these things.
Okay. So would you agree? So whenever I hear this made by apologists or philosophers like William Lane Craig, the first premise is it assumes fine-tuning, like you said, most people agree. And it says the fine-tuning of the universe is either due to physical necessity, chance, or design. Would you agree with that premise?
Yeah, I think that's a useful way to lay things out. Yeah.
Yeah. I can't even conceive of a fourth option, but is there one?
Well, most of the time when people look up a fourth option, I mean, it's kind of either it's evidence for God or it's not.
Right.
If it's not evidence for God, it's because actually it's not as unlikely as we thought, and so it can just be chance, or we just accept whatever the probabilities there are and don't care, or there is some reason that actually makes it highly probable. So I think there's a way of just dividing things up where actually if you make the chance and necessity camps big enough, they'll basically cover all the options.
Yeah. I guess apathy is always an option. I just don't care. So let's look at some of the objections I hear a lot on the popular level, at least. I don't know if you hear them in academics or scholarly circles or not, but one of them is, how do we know that the fine-tuning isn't due to something like physical necessity? How do we know that they actually could have been different?
So I think I think the way to deal with this is to say, it could be due to physical necessity, but there's no guarantee of that. In particular, some people want to say that the progress of science will automatically answer fine-tuning. Mm-hmm. And that's not been the case in the past. So before 1998, for example, it was possible that the cosmological constant was actually equal to 0 in our universe. We didn't have the evidence one way or another. And if it's 0, it's possible that there's some deeper symmetry which sets things exactly to 0. Setting something exactly to 0 is kind of an easier thing to do. But after 1998, when we discovered that actually its value in our universe is not 0, suddenly now there's a real cosmological constant problem. One of the ways of getting around that problem has been removed. And so actually the progress of science made a fine-tuning case worse.
Yeah.
And so I certainly wouldn't want to say if the objection is that the future progress of physics will automatically make fine-tuning a problem that is solved, then that's just simply not true. It is quite possible that there is some final theory of physics which we write down on a blackboard, and when we look at changing the knobs and dials or the structure of the equation or whatever, we find fine-tuning there as well at the deepest laws of physics. But it's possible that so, for example, we've just gotten to like electrons. Let's change the dial for electrons. Maybe there's some deeper theory which tells us why the electron has the value that it does. Now, all that means is if we want to ask the fine-tuning question, we now need to ask it at that deeper level rather than at the level of electrons. Now, because we don't have that theory, maybe things turn out okay at that deeper level, but all that's asking for really, it's asking for another rematch. Right? We started with the amazing natural world. We went to the deepest physics we have, and things are still looking pretty bad. We now want another rematch in terms of physics that we don't have.
Right.
And we say, oh, when we get that theory, everything will be fine. And there's no reason to believe that's true. Yeah. And if you can pull that, if you can pull that move, you can get away with anything. So
yeah, pretty much.
That's the way I'd frame it.
So another popular objection or appeal is the appeal to the multiverse, and I of course don't know anything about the multiverse, not a scientist, of course. Does the multiverse make the astonishment of the fine-tuning disappear?
So I guess again it's asking for another rematch. Like the natural world looks amazing. The physics and cosmology of our world looks amazing. Let's go to a deeper theory where there's, life is amazing. Well, our universe is a life factory, and then our universe is amazing. Well, maybe there's a universe factory.
Yeah.
And that's where we're at. And so the question to ask there is the same question that we asked about the watch factory. Like, do you get nice universe factories for free?
Yeah.
Are they the sorts of things that you can get? And the problem is that we don't have, with the physics of our universe, we have the standard model, and it's called that because it is the standard, right? We have a model which is extremely well tested, almost, ridiculously well confirmed. Quantum field theory, general relativity, particle physics, expansion of the universe, it's all working beautifully, right? No, nothing's ever perfect, but it's pretty good. We have nothing like that for the multiverse. And so once again, you're asking for a rematch in an arena where there are no rules yet. So you can sort of see how that argument, how the multiverse is supposed to work, right? I mean, how do people win the lottery? Lots of people buy different tickets. And so the probability that the right ticket turns up somewhere isn't too low. And so our astonishment that someone won the lottery sort of disappears a bit. And with fine-tuning, that can kind of work, right? If there's a multiverse, the fact that a life-permitting value of the electron mass, for example, the fact that that turned up somewhere is no longer surprising. The problem is if we're still thinking through that, okay, life is amazing, the universe is amazing, is the universe factory amazing? That's now not the question to ask. We've now, you asked for a rematch. Let's really do the rematch. We need to ask whether the universe factory is amazing. And if you don't have a good model of it, we can't ask that question. So once again, it's asking for a rematch where there are no rules.
Yeah, for sure. One thing I hear sometimes is this so-called Puddle analogy. Are you familiar? I'm sure you are. I'm sure you've heard them all.
Yeah.
Well, I'll let you explain what the Puddle analogy is and why it doesn't work.
So there's a famous quote from Douglas Adams, who wrote The Hitchhiker's Guide to the Galaxy, and if I can find it very quickly, I might as well actually read the whole thing out.
Sure.
He gave it in a few different places. So here it is. So Douglas Adams, who I have the highest respect for, he's a brilliant writer. Well, he was. Sure. But he said, this is rather like as if you imagine a puddle waking up one morning and thinking, this is an interesting world I find myself in, an interesting hole I find myself in, fits me rather neatly, doesn't it? In fact, it fits me staggeringly well. it must have been made to have me in it. This is such a powerful idea that as the sun rises in the sky and the air heats up, and as gradually the puddle gets smaller and smaller, frantically hanging on to the notion that everything's going to be all right because the world was meant to have him in it, was built to have him in it, and so the moment he disappears catches him rather by surprise. I think this is something we need to be on the watch for. So, like, very clever quote. I think the point he's making here is not really a point about fine-tuning. It's a point about the sort of person who thinks... I mean, there's an environmental kind of message here at the first level. You know, don't think that just because the Earth is nice that we can't ruin it ourselves,
Sure.
or that we don't have to look after it. I think that's the point he's making. When you try to apply this to fine-tuning, there's another problem here. Again, you're appealing to a explanation that you don't have. So for the puddle, there's a coincidence between the shape of the puddle and the shape of the hole.
Yeah.
Okay. And wherever the puddle has a little bump, oh, look, the hole has that same little bump there, right? Yeah. The solution to that coincidence is to realize that actually there's not really any such thing as the shape of a puddle.
Right.
Like, it's a liquid. And so given the liquid that the puddle of water is a liquid, and given gravity pushes everything down, and given that the hole is solid, it has to be the case that the puddle fits the hole. Okay, interesting. Let's apply that to the universe. There is a coincidence between the properties that our universe actually has and the properties that it would need to support life. Okay, if we now apply that sort of thinking there, it has to turn out that one of these things is really kind of a fluid, right? You don't really need to fine-tune a universe to make life. Any old universe will do to make life in it. So the analogy there with the puddle is any old hole can hold a puddle. You've just got to be a hole. If that was analogous, any old universe would be able to support life. And that's false. The problem with the analogy is it's not analogous. Analogous. There's, you're supposed to. You've given us a blueprint for an explanation, and when we try to apply it to the universe, it doesn't fit. Unless there is a multiverse, and you've got a good multiverse theory, and you can do all of that sort of right, then it's sort of any old. It needs to be the case that any old multiverse will eventually turn up with the life-permitting universe. And it's still not quite the same, but at least that might work. So the problem with the puddle analogy is that it's not analogous. It sounds clever.
That does sound clever. Yeah.
It just doesn't apply to fine tuning.
Yeah, for sure. The next one is kind of similar. It's funny how all these end up being analogies. Analogies aren't really objections, by the way. But this says, what about the lottery objection? So the way this goes is the odds of winning the lottery are extremely improbable, whatever they actually are. But somebody has to win. If I buy a ticket and win, am I to conclude that the lottery was rigged because the odds of it happening by chance were so low?
Right. So... one thing which is a pet peeve is here, no one has to win the lottery.
Right, that's what I was going to say. As I was reading that, I was like, wait a second, you don't have to win. But go ahead.
But even that case, if I buy the lottery, so suppose I win the lottery. Let's do it independently. Bob over there, Bob just won the lottery.
Good job, Bob.
So now, great work, Bob. Actually, if you look up a picture of the guy who did the largest ever lottery win, it's like $160 million, and he's holding this giant check, and he has the most sour look on his face. It's amazing, like smile.
He's probably scared.
Anyway, yeah.
I would be.
Well, there's a proverb in Proverbs somewhere, and
something more about that. Yeah,
a rich man's. The wealth of a rich man may ransom his life, but a poor man hears no threat. And I think of that every time I think about a lottery winner. Like, if I ever won the lottery, no one would hear about it. Anyway,
I read myself that proverb every time I check my bank account balance. But go ahead.
Yeah. We're still waiting on the lottery to come through from the book. Anyway, so Bob's won the lottery. And now we've got two hypotheses. One of them is Bob just bought any old ticket and his numbers came up and Bob won the lottery. And the second one is the lottery has been rigged to make it almost certain that Bob will win.
Right.
Okay, those are our two hypotheses. Now, on a first level, the first thing you do is you say, all right, what's the probability of the evidence given the hypothesis? And on that level, the probability that Bob wins, given that he just bought any old ticket, is that very small probability, whatever it is, 1 in a billion, say.
Okay.
On the second hypothesis, what's the probability that Bob wins, given that the lottery has been rigged in favor of Bob? That's a very high probability just by construction. That's the hypothesis. And so it seems like at that level, we've got evidence that someone rigged the lottery for Bob, maybe Bob himself. The problem is that's not the only question we ask about the hypotheses. You have to ask what their in sort of prior probability is within Bayesian probability theory, their intrinsic probability. So you say, okay, ignore the fact that we know that Bob has won the lottery. Let's take that little bit of evidence and just shelve it for a while. We dealt with it before, but for this thing, suppose you didn't know thing. What's the probability that Bob would just turn up and just buy any old lottery ticket? Well, billions of people do that every day, so that's fine. Yeah. What's the probability that someone rigged the lottery for Bob? And so here's the thing.
Yeah.
If you have to take two things into account there. What's the probability that someone rigged the lottery, and what's the probability that the particular person that they rigged it for is Bob rather than Jose or Karen or Fred or whoever? And so the probability that someone could rig the lottery is low because lotteries aren't a complete sham, presumably. But then the probability that someone rigged it for Bob rather than someone else, in the absence of any other information, is roughly on the order of 1 over the number of people who buy tickets.
Right.
So if 1 billion people bought tickets, the probability that it was rigged, given that it was rigged, the probability that it was rigged for Bob in particular, in the absence of any other evidence, is extremely low.
Okay.
Because why think that it'd be rigged for Bob rather than rigged for Fred or Karen or
Okay,
Bill?
let me repeat what I think you said. So we have to take into consideration that there are, and we don't actually know because we probably have, or I haven't at least looked into how the lottery actually works, but presumably there are controls in place to make sure that people don't rig the lottery.
Yeah.
And even if somebody did somehow get around those controls, you would still have to calculate what the probability would be that they would rig it in favor of Bob as opposed to anybody else. So perhaps, and I guess this is how prior probability works, if Bob was the husband to the president of the lottery, who is then maybe his probability is higher than like my probability because I have no connection. Okay, but given that we don't have that kind of information, so there's controls in place, and then you also have to calculate why it would be rigged in favor of him. Okay, go ahead. Sorry, just wanted to make sure I understood that.
Yeah, good. So that's the setup. That's why when some random Bob wins the lottery, we don't all immediately say, it must have been
cheated.
rigged.
Yeah.
Yeah. So in particular, so the example of Bob is the husband of the lottery president, say, is a good one. So moving over to fine tuning, we have the case. So Bob just won the lottery at random is a bit like our universe just picked any old numbers and we got the right ones just at random. The equivalent of this lottery was rigged for Bob is, I assume, the equivalent of, God set up the universe with just the right numbers in order for there to be life. So in this case, the question that we're led towards is, what's the probability that there is a God at all? And that's sort of always lurking in the background. And in particular, the equivalent of, okay, if the lottery is rigged, why I think it's rigged for Bob is analogous to assuming God made a universe, why would God make a life-permitting universe?
Right.
Now, if that probability is extremely low, then the argument goes nowhere. Okay? In the same way that the accusation against Bob goes nowhere. But if there is some sort of natural connection between God and a life-permitting universe, which makes us think that that probability isn't very low, then we're in business. That's the equivalent of it turns out that Bob is the husband of the president of the lottery. Now there's some natural connection between the two, which leads us to think that, oh, hang on, if this thing was rigged, there's a reason to think it would be rigged for Bob.
Yeah.
And so there's a step in this argument you've got to make, where you've got to say, all right, if God made a universe, what's the probability that God make a life-permitting universe? And for me, that step isn't particularly hard to make. Once we've pulled it all apart and isolated that little question, actually, like, the fact that so many theists are so happy with fine-tuning and not bothered by it at all says that they don't, no one thinks that this is a problem. No one who actually believes in God goes, oh, I think it's extraordinarily unlikely that God would want to create a life-permitting universe. The best specific defenses of this point, I think, come from Robin Collins, who talks about embodied conscious agents. So if you want to have an agent that can do moral things like interact with someone else, it has to do that in an environment in which, I can choose to give you a meal, or I can choose to give you poison, and there's consequences to those actions. And a similar sort of argument is made by Richard Swinburne. That's a bit more of a theological argument, but I don't think that's a problem for the argument.
Okay. I guess I'm still left actually a little bit confused. I thought we were going one direction. We kind of went a different one. You went to the defense of the theistic side of that, but what was actually the answer? What was actually the answer to the or the objection to the lottery analogy? I guess I missed it. Maybe I may not have been following. Sorry.
So I think in the case of the lottery, So the objection, as I take it, is when someone wins the lottery, we don't immediately say that the lottery is rigged.
Correct.
And so we seem to have won the universe lottery, but we shouldn't automatically go and say the lottery is rigged.
Right.
So when we pull that apart, actually sometimes when someone wins the lottery, we would say it is evidence that the lottery is rigged. And it's when you have this connection between, if the lottery was rigged, it's likely to have been rigged for that specific person. Mm-hmm. And the analogy is, if God would made a universe, it's likely that God would make a life-permitting universe. And if you don't think that's particularly unlikely, then actually the argument does go through. You do have the analogous case of the lottery is rigged, does look rigged, if you have this connection between Bob and the president of the lottery.
Gotcha. Okay, that makes sense. Okay, so is this a how is it, or suppose, I guess the correct way to ask the question is, how is this not an argument from ignorance? We don't know how these constants became fine-tuned, so therefore God. So a God of the gaps, essentially. I just really hate using that terminology. I think the correct terminology would be an argument from ignorance. So how is it not that?
So I think there's at least a big difference between this and the other sorts of arguments. Is we're not saying that there is something in the universe which our current theories are unable to account for, or our best understanding of the natural world would leave it unable to produce. So, for example, if you thought that the origin of life is evidence for God, because, and there's different ways of running this argument, but if the way you're running it is, we can be reasonably sure that the natural stuff of the universe wouldn't actually make life just left to itself, you're essentially arguing for a miracle. So you're saying our best understanding of natural things, and then here's this natural thing that has actually happened, and this can't make that, but this exists, right? The stuff of the universe can't make life, but life is here, so something miraculous must have happened. That, for me, is a God of the gaps argument. Again, that gives it a bad rep. Actually, I think it's valid. If its premises are true, then it's fine. Right. It's just, I mean, sometimes So, sometimes, in a sense, all arguments are of the gaps arguments.
Right.
Whenever
If
you
you're
say,
inferring
yeah,
something, yeah.
yeah, you know, um, if the atmosphere didn't have the properties that it has, then the sky wouldn't appear to be blue. So it's that's an of the gaps argument that if
Right.
you if the if we don't suppose that there are these properties of the air in the atmosphere, then
Uh-huh.
we fail to explain something.
Yeah.
There are better and worse of the gap style arguments, but it is kind of valid. But here's my point: fine tuning isn't that sort of argument. We are not saying that the natural things that we know about could not have produced um, the universe we see around us. We're
Right.
not saying that there's a gap in science. We're not saying that there's something that scientific theories can't account for. We're going to the deepest level of science we have and assuming that that perfectly describes our universe, and then saying, all right, what can we infer from that fact?
Yeah.
We're not even assuming it perfectly describes our universe. We're just saying let's just treat that as the best information we have and go from there.
Yeah.
So it's precisely built on what we know about the universe.
Yeah.
It could be the case that what we don't know overthrows what we do know, as in, maybe some deeper law leads us to reevaluate fine tuning, but that it's always true that what we don't know might
Right.
interact with what we do know.
We hold all of our beliefs in some sense to tentatively or something like that. Yeah.
Yeah.
Okay.
Unless you've got a mathematical proof.
Right.
Unless
There's
you've got a
something
mathematical,
yeah.
there's no chance that we get some new information tomorrow which overthrows Pythagoras' theorem.
Right.
Other than that realm, mathematical and logical proof, it's always true that something could turn up tomorrow which
Sure.
Overthrows us. But that's not, that's always true. And as I point out, deeper discoveries about the way our universe works will not necessarily result in a non-fine-tuned universe.
Correct. Yeah. Okay. So the next question is perhaps a theological question, actually, but it is: how can you say that the universe is fine-tuned for life when most of the universe is hostile to life? Or at least this is what I hear people object. Yeah. How do you answer that?
If you understand why some bits of the universe, actually most of the universe, is hostile to life, then you're sort of one step away to understanding why our universe is fine-tuned for life. So if you can see why life wouldn't have a very nice time in the empty spaces between, the galaxies, for example, then, okay, imagine a universe which was entirely like that, where there was no galaxies and no stars and no planets. It was all like empty space with a couple of particles floating around, and that's all there was to the universe. And if you can see why that's hostile, you can see why there can be universes which are entirely hostile. And then you can see that the cosmological constant problem, the fine-tuning of the cosmological constant, says most universes are like that. Most universes are that sterile, nothing happens at all in that universe. And so if you can see why bits of this universe are hostile to life, you can see why there is something remarkable about the fact that our universe has non-hostile bits at all.
Yeah.
So there's a few things to say here. One of them is, it's no part of fine-tuning to say that our universe has the optimal amount of life. Like this is the maximum amount of life you can just pack into a universe. There's a certain fraction of our universe which is permissible for life, friendly to life. It's a small fraction, but what would you expect it to be? Would you expect it to be like 50-50? We're all just jammed in cheek by jowl. So the other thing is, there is a role that the empty bits of the universe play in making the friendly bits friendly.
Yeah, that's what I was going to say. Is there something like it may be the case that the universe had to be this way just for life to exist at all right here? I don't know. I'm not the scientist, but go ahead. Yeah.
I wouldn't say it had to be this way. It's a bit too strong.
Okay.
But what I would say is, in this way that our universe is put together, which we see around us, which is has Earth in it, and Earth is doing fine, there is a role to play for empty space. If the whole solar system were filled with air, breathable air like the air in this room, we could go exploring out in space and breathe the air. The problem is there would be wind resistance against the movement of the Earth around the sun, and after about a month, it would spiral in and go into the sun. And so there's a reason why there's no air
Yeah.
out there. Like,
I
there's
never would
plenty
have thought of
down
that.
here.
That's funny.
You're fine. Yeah. You also wouldn't be able to see very far. I mean, we think of air as transparent, but actually it starts to cut down the amount of light that comes through after about 100 kilometers. So you're fine on Earth because the curvature of the Earth means you almost can't see 100 kilometers through air in a straight line. But if the whole universe was filled with air, you wouldn't see a clear picture of the universe around us. You'd at best see a sort of fog. I guess eventually the sun would heat up the air or something weird like that would
And then we
happen.
wouldn't be having this conversation because we wouldn't know about fine-tuning,
Yeah.
presumably.
Yeah. The other thing is, in the overall expansion of the universe, the rate at which the expansion is decelerated depends on how much stuff you put in the universe. So the more stuff you put in, the stronger a pull it has to pull back the expansion. And so if you fill a universe with, even stuff as dense as air, which is incredibly more dense than the universe as a whole, you either have the universe expand and recollapse in a day, or you have to make it expand so fast that nothing forms. Like, you have to expand it. It has to double in size basically every day. That's not quite right, but anyway. Basically, it'll go way too fast. You have about a day for structure to form.
Yeah.
Right, and the structure we see around us took billions of years to form.
Yeah.
So it's not that the universe had to be this way, but within the logic of our universe, the bits that don't have life in them have a role to play in making the life-friendly bits life-friendly.
Sure. Yeah. Okay, one last question before we go to the bonus segment. Again, for the audience, if you want to watch the bonus segment, just follow the Patreon link in the description below labeled Support Help Me Believe and become a patron, and you can get access to not only this bonus segment with Dr. Luke Barnes, but also all of our previous bonus segments as well as all the future ones. You get early release and stuff like that as well. All sorts of stuff going on over at Patreon. But before we get to that, Dr. Barnes, one last final question here for the interview. How far does the fine-tuning argument get us as far as deism, theism, monotheism? How far does it get us?
I think at worst it gets us as far as deism. At worst. So, sure. I mean, we're dealing with a mind who is able to set the fundamental constants of nature. And so to say that mind would have to be the creator of the physical reality, I think is at least strongly, at least a simple option. No one actually defends this, but you could say that there's just some finite creator, but then you get all sorts of problems there. I think that's a less simple hypothesis. The crucial step for me is actually the one we talked about before. You do have to say, all right, if there was a creator of a universe, what's the probability that creator would make a life-permitting universe, and what a creator universe with moral creatures in it? Yeah. And I think if you have a version of theism in which, basically the moral realm is a highly valuable realm, if moral things are very valuable things, and so God would want to make a universe in which had moral value as creatures like us who are capable of moral actions, then that step of the argument gets easier. And so I think at that point the theist makes the argument more easily than the deist.
Sure.
So I'm not sure if that gives theism a one-up on deism, but
I think it does, but that would be kind of an additional thing, right? You would have to go to morality, which is, I suppose, outside of the fine-tuning question, right?
Well, not quite. It's not the moral argument. I mean, we're not saying that we need moral value to exist. It's just the question: if the God of deism were true, what's the probability it would make a life-permitting universe? And if the God of theism is true, what's the probability that God would make a life-permitting universe? And I think a theistic God who is the source of, I think of a deistic God as just, it could be like the force or whatever. Oh no, I guess it's got to be thinking. Anyway, if there's some sort of if your idea of God is the idea of a God who is the ground of moral value, we don't need that to be, you don't then add to that moral values exist, therefore God exists. We're not running the moral argument yet, although feel free. We're just doing an internal thing. If that God exists, then the connection to a moral universe is easier to make.
Sure. Yeah, that makes sense. Okay. Well, again, thanks so much for joining me. And again, for the audience, if you want to watch the bonus segment, 5 More Minutes with Dr. Luke Barnes, be sure to follow the Patreon link in the description. Check out his books, which will also be in the description, and go over to check out his bio and his website as well. Dr. Barnes, thanks so much for joining me, sir. I really appreciate it.
Thank you very much for having me.
Thanks so much for joining us. If you enjoyed the episode, be sure to hit the like button, subscribe, leave us a review, and of course, if you want to watch the bonus segment, 5 More Minutes with Dr. Luke Barnes, be sure to follow the Patreon link in the description below, labeled Support Help Me Believe, and become a patron supporter. Thanks so much, and we'll see you next time.